Okay, today I am going to be going through the Level 1 Mathematics and Statistics 2016 Geometric Reasoning paper. You can feel free to forward. I'm going to go through question by question. So this is question 1. Please make sure that you have actually at least tried to do some of these things. I'm going to go over some of the thinking that's required, but it would be really, really good if you actually give it a go first before you look through this. My classes, I have actually got this on our OneNote page, so please feel free to go and have a look at all the workings that I've done. It should be on the OneNote page as well, but this is the video of me doing it, so whichever one works better for you. So let's get on with it. I'm going to start on page 1, which is a beautiful picture of the Scar Tower, which I'm sure you've all seen living in Auckland. So question 1, the base of the tower is supported by 8 legs. They are L meters long, so they've actually very nicely given us a diagram of this, and you can see that they've marked the L, and I'm hoping you're thinking, what part of the diagram is that? What part of my triangle is that? The legs are joined with the tower. Blah, blah, blah. So just having a look at this, I want you to just first of all think, what are we given here? Looking at this diagram, what can you see? I'm hoping you notice you've been given this little right angle here. So we've got a right angled triangle. We've got an angle over here that I'm trying to find. I've also got a side that I'm trying to find. Now, obviously, the first question is specifically asking, calculate the length L. So we are wanting to know what that length L is. So I have got a right angled triangle. I have got 2 sides given. I am trying to find the third side. So as soon as you've got right angled triangles, remember there's 2 things that you could be finding. So this is my little thoughts that I'm doing right now. I'm either doing Pythagoras or I'm doing trigonometry. Which one am I going to be using for this question? Well, Pythagoras, remember, is looking, if I've got, it's all to do with sides. There's no angles. And in this case, I've been given 2 sides. I'm trying to find the third side. So it's definitely just going to be Pythagoras. So at the moment, I'm not worrying about trigonometry. And remember, it's my 2 short sides squared added together. Is equal to the hypotenuse squared. So looking at this diagram, remember the hypotenuse is always the one opposite my right angle. So that is my hypotenuse. So L is actually the hypotenuse. So it's going to be 43 squared plus 3 squared equals L squared, which is my hypotenuse. So if I get out my calculator and I am just going to go into the main thing. So it's going to be 43 squared plus 3 squared equals, okay, so that's going to give me 1858, was it? Please still be there, yep. 1858 equals L squared. Now, I don't want to know what L squared is. I just want to know what L is. So I need to square root each one. Please just keep that in your calculators. You just have to go shift that one over there of my answer, which again is going to be shift and then answer down the bottom there, equals 43.1. Now, they are both in meters, so I know that that is in meters as well. So there is the first part of my question done. Now, the second part is actually says use trigonometry. Now, they won't always say that specifically, but we know if we're trying to find the angle X this time, I'm trying to find an angle, so I need to think about what I'm doing this here, so I'm going to be using an angle. Now, I've got all 3 sides because I have just calculated what that L is, but it's a good idea if they have given you the other 2 sides to try and use ones they've given, because if you have made a mistake or you've rounded differently to how they want to round, it's going to give you a different answer. So try and use what they've given. Obviously sometimes it won't always work, but if we're trying to find angle X, remember we need to label our triangle in terms of this X here. So that one, this 3 meters is my opposite, and this 43 is my adjacent or attached. It's joining to that. So that is my adjacent. I don't have to worry about my hypotenuse. I have calculated it, but I've got my opposite and adjacent, so I'm going to use that. Now, let's just have a little think. We have our SOHCAHTOA, and in my SOHCAHTOA, I'm looking for opposite and adjacent, so not that one, but that one over there will do very nicely because it's got an opposite and adjacent in it. So I'm going to fill in my triangle here, and it's going to be tan of X. My adjacent is 43 and my opposite is 3. My adjacent is 43 and my opposite is 3. 43 and 3. Okay, so, and this is tan of X. We don't know what that is at the moment. So it's the tan of X that I'm trying to find, so I'm just sort of color that in. So tan of X is equal to, they are on top of each other, so it'll be like that. And to undo the tan, remember, we are going to inverse tan, so it's going to be tan to the -1 of 3 over 43. So get up my calculator, and I'm going to go shift tan, and it's going to be 3 over 43. So I'm just going to put my 3 divided by 43 and close my brackets, equals, I probably should check what my calculator's in. Shift setup, I've got it in radians, that was why it looked funny. So if I just go down to there and I go to degrees, and I go enter again, it's going to give me the actual angle. So 3.99 degrees.